Hi, my little geologist. Well, normally you'd be seeing a video of me in the bottom right corner, but my webcam is kind of acting up, so you're just going to have to deal with the creepy voiceover. So, some of you have already started on this project, and that's okay, that's good. What this video is going to serve for is it's going to help you understand a little bit better how to go about this activity, really. So some of you haven't had issues researching and finding these things, and so what Mrs. Schaefer and I decided would probably be the better route is if I were to record some video notes for you over how to do this activity and how to do the research for it and how to find what you're looking for and really be successful at it. So that's what this is all about. We're going to do the first one together. But of course, we always read the directions first. So, is it a mineral? In this activity, you must determine whether the substance is a mineral based on its characteristics. A mineral must have all 5 of the following characteristics to be a mineral: be naturally occurring, be a solid, have a crystal structure, formed by inorganic processes, and have a definite chemical composition. Research the following substances and determine if they are a mineral or non-mineral. Place an X in each box that pertains to the substance. Note: you are not allowed to simply Google "is blank a mineral?" That is cheating. On the next page, copy and paste in the website URL of each resource you use to find your information. Okay, so that's pretty straightforward. Now let's look at our table. Our table here gives us 8 examples of different substances that you need to determine if they're minerals or not. And I also see that we have 5 columns, one for each of the different characteristics of a mineral. So we're going to do quartz together. Now the place I like to start is I like to look at my different columns, categories, and see if I know any of them right off the top of my head. For some of these, you are going to know right off the top of your head, especially the solid, for example. Solid, most of the time you'll know if you don't already always know. So, I'm going to go through here. Do I know if quartz is naturally occurring? I'm not quite sure. I do know that quartz is a solid because I've seen quartz crystals. So, yes, quartz is a solid. Has a crystal structure. Now that sounds kind of familiar to me. I'm thinking, what does a crystal structure mean? That makes me think of crystalline solids, right? So now I'm thinking back to solids. There are 2 types of solids, amorphous and crystalline. Amorphous solids don't have any sort of repeating pattern in their atoms, and they have examples like rubber, butter, that sort of thing. Crystalline solids, on the other hand, have a very set repeating pattern of atoms. And examples of that were like snow, salt, sugar. And there was one other example that Mrs. Schaefer gave us for crystalline solids. Anyone remember what it was? It was quartz. So if quartz is a crystalline solid, that means it has to also have a crystal structure. So I could put an X in that one too. Now I already have 2 of my 5 down. Now comes the hard part, the research. So the way I go about this, the way a lot of you actually have gone about this to start, is you've typed in something like, is quartz naturally occurring? And this is telling me that not all varieties of quartz are naturally occurring. Some are, but some aren't. And that's kind of confusing to me. So instead of just Googling, is blank naturally occurring, does blank have a definite chemical composition, it'd be better to ask more open-ended questions. Google doesn't do very well with simple yes and no questions. It's better at giving you open-ended questions that it can give you definite answers to. So, instead of Googling, is quartz naturally occurring, let's look at the way that quartz is formed. So I'm going to type in quartz formation. And this is telling me that Most mineral crystals grow from molten rock deep within the earth. As magma cools, many crystals form simultaneously and crowd to one another, producing irregular shapes. So that's telling me that quartz crystals form deep inside the earth when magma cools. For something to be naturally occurring, that means that humans can't have any part in making it. It has to happen all on its own. Well, since there aren't any humans deep within the earth that's, blowing on the magma to cool it down, that means that it has to be naturally occurring. So what I'm going to do is I'll put an X in my quartz, and then I'm going to go back to my quartz formation and find out where that source came from. So according to Google, it came from, how do crystals grow? So I'm going to take this, I'm going to copy it, and I'm going to slide down here, and I'm going to paste it. And look at that. Now we have 3 done. Oops. There we go. Next question. Formed by inorganic processes. So let's break that down. What does that mean? Well, if something is formed, it's made by inorganic processes. Now, inorganic is kind of a big word, and you may not be familiar with it as much as you are familiar with organic. So for something to be organic, that means it has to be living. So take, for example, a lot of times when people go to college and they want to major in some sort of science degree, they have to take something called organic chemistry, which is it's chemistry of living things. That's the same idea. Organic is something living. So inorganic means what? That it's not living. It's formed by not living things, is what formed by inorganic processes means. So let's go back. And believe it or not, we don't have to go very far for this one. Let's look back at our quartz formation little Google pop-up that it gave us. It says that most mineral crystals grow from molten rock deep within the earth. As magma cools, many crystals form simultaneously and crowd into one another, producing irregular shapes. So, I ask you, is magma living? What is magma? Well, magma is, you know how volcanoes, they shoot out lava? Well, magma is what's inside the earth before it becomes lava when it shoots out of the volcano. So, the question becomes, is magma living? Well, last time I checked, magma doesn't get up, crawl itself out of the ground, and then threaten to blow up Tokyo or anything. That doesn't happen. Magma's not real. Or magma is real. Magma's not alive. So that's telling me that magma's inorganic, and it's making quartz formed by an inorganic process. So I can put an X for that one. Now for the last one, definite chemical composition. What on earth does that mean? So let's break this one down too. If something is definite, it doesn't change. Think back to your solids, liquids, and gases. Solids had a definite shape and a definite volume. Liquids have an indefinite shape but a definite volume. And gases had an indefinite shape and an indefinite volume. That means that solids, their shape and volume don't change. For liquids, their shape changes but the volume doesn't. And gases, both the shape and volume do change. So for something to be definite, it can't change. It has to be set in stone. So chemical composition. Well, chemicals, you guys remember talking about that. I taught that lesson all about elements and stuff like that. Elements and compounds and whatnot. That's all chemicals. Composition. A composition is kind of what it's made up of. So definite chemical composition means that for a substance to have a definite chemical composition, it must have a set configuration, or it has a group of elements that come together in a certain way that is the same for every single instance of that substance. So, we ask ourselves this. Are the elements that make up quartz the same for every single quartz crystal? Well, that's what we have to find out. So, can we type in, does quartz have a definite chemical composition? No. So instead, let's type in chemical composition of quartz. So much easier. Google already popped it up for us, that the chemical composition of formula is silicon dioxide, SiO2. So, we can say that yes, quartz does have a definite chemical composition. And then I'll go back here, click on this, copy over the URL, slide down here, paste it over, and that's it. So then I'll go back here. Quartz is naturally occurring. It's a solid. It has a crystal structure. It's formed by inorganic processes, and it has a definite chemical composition. What does that mean? Well, that means that quartz is a mineral. Awesome. So then we move on to the next one. And you're just going to follow that same path. Instead of the biggest takeaway that you can take from this video is this. When you're doing research to find these sort of answers, it is best to not use yes or no questions. Instead, you want to use questions that are going to produce a short answer, or an actual answer other than yes or no. So instead of typing in, does quartz have a crystal structure, that tells you nothing, you can type in crystal structure of quartz. And I can click on this. And it's crystal structure right there. Loud and clear. You can't miss it. Alright guys, so the rest of it is up to you. Make sure you don't forget the questions at the bottom, and you don't forget your resources. If you have any other questions, feel free to come find me. You know where I am. Alright, good luck guys. I'll see you on the flip side.